Time is a simple thing, right? And working with it in Python is great. You just import datetime and, somewhat oddly, use the datetime class from that module. Oh, except there are times with time zones and times without time zones. And why is there a total seconds, but no total minutes, total hours, or total days on time delta? How about computing the number of weeks in a time span? What if you wanted to iterate over the next 21 workdays, skipping weekends? All right, we'd better talk about time in Python. Good thing Paul Ganssle is here. He's a core developer who controls time in CPython. This is Talk Python to Me, episode 271, recorded June 18th, 2020. Welcome to Talk Python to Me, a weekly podcast on Python, the language, the libraries, the ecosystem, and the personalities. This is your host, Michael Kennedy. Follow me on Twitter where I'm at mkennedy. Keep up with the show and listen to past episodes at talkpython.fm, and follow the show on Twitter via @talkpython. This episode is brought to you by Brilliant.org and us with our online courses over at Talk Python Training. Speaking of Talk Python Training, have you been thinking about taking one of our courses? We're participating in the latest Humble Bundle deal for Python developers, along with a bunch of other great educators and tool developers. Until July 22nd, you can get $1,400 worth of Python goodies, including 3 of our popular courses for just $25. Yeah, Humble Bundles are crazy. That's $25 for our 3 courses and all those other things combined. Just visit talkpython.fm/humble2020. That's talkpython.fm/humble2020 altogether before July 22nd to take advantage of this offer. Now, let's get to that interview. Paul, welcome to Talk Python to Me.
Glad to be here.
Yeah, it's great to have you here. Really excited to talk about the meaning of time and all of that. Time is really tricky, actually. Time's one of those things that seems really obvious and simple until it's not. And then until you start working with it and you're like, oh, actually that code's running on the server, and that server we forgot, we didn't set the time zone to actually where it is. So maybe it's UTC, maybe it's where the server's located or where our office is. And all of a sudden you find yourself juggling all these things. And especially if you're building anything that has to do with calendars or stuff like that, that's going to be a real adventure.
Yeah, well, I will say that I did not set out to become like the datetime guy, but I think that kind of complexity, like the natural complexity of the subject it's either drawn me in, or what's the word for when something gets you stuck, like in a quagmire or like a Venus flytrap or something.
It's enticed you in, and now it's got you trapped in its world. Yeah,
it certainly seems like a one-way function, like something barbed where you can move in one direction but not in the other direction.
Yeah, for sure. Well, it's really great that you're working on it. And just for the listeners, so you're a Python core developer working on basically times, date times, time spans, that kind of stuff in Python.
Yeah, I think I originally got into it with working on Util, so I've been maintaining that for about now it's like 6 years. And, Util has a lot of little minor extensions. And then when PEP 495 came around, the core developers showed up in Util and said, hey, we kind of used your library as a prototype for how this could work. So maybe you want to actually implement PEP 495. And then I did that. And then I had a relationship with the core developers. And then I just kind of stuck around and started doing more stuff. And eventually, it's one of those things like you never set out to do it. And I don't even have a job that's particularly datetime heavy. It's just like if you start monitoring the issue tracker for something like Util or even CPython, and then specifically just focusing on any one thing, like you'll just learn a stupidly large amount about edge cases and how everything works.
I can see how that happens. And it's definitely one of those things that pulls you in. Before we dive too much into all of that, though, let's start with your story. How did you get into programming in Python?
I knew this question was coming, and I was sort of dreading trying to answer it because I feel like every time someone asks me how I started programming, I give them a slightly different answer because I've had quite a bit of false starts. Like I had when I was a kid, they taught us BASIC, and I sort of remembered enough of that. And then, so I didn't go to high school, but when I was sort of in place of high school, going to like a homeschooling center every once in a while. I guess I shouldn't say every once in a while. I was regularly going to a homeschooling center. I started learning C++. And then weirdly, my friend became close friends with someone who was what they call the wizard on a MOO, which is a MUD, but object oriented. and MUD stands for multi-user dungeon, I think.
I don't know if the young people listening these days will know what a MUD was, but man, MUDs were super fun back in the early days.
Yeah.
See if you can describe a MUD to people listening who have never played it.
Yeah, so a MUD is a text-based game that you would like connect to via like Telnet or something. It's kind of like Zork or some sort of, if you don't know what a MUD is, you probably don't know what Zork is either. But, like it's a text-based game where they describe, it'll say, like, oh, you're in a room, you can go north or south, and you'll go north, you'll pick up an object or something. So it's like kind of a fantasy game or a Dungeons and Dragons type thing where it's all text-based. And then you can also talk to other people there.
Yeah, and there's usually potentially hundreds of people all running around. They might be in these rooms, and you can have battles, you can go on quests. One of the hallmarks, I think, is it's not super obvious what you can do. It's not like, well, here are my 5 commands. You kind of have to interrogate the game with words to figure out, like, oh, there's actually a rock and I could move the rock. I didn't know that, but now that kind of stuff. What I liked about it was as great as graphics are on games these days, it really just leveraged your imagination. And yet there were other people there and stuff. I thought it was pretty cool.
Yeah. Well, so I actually got into that stuff like after the heyday of MUDs, like when there was like not that many people in there. It was just my friend had this was running. It was basically a chat server that you could just build whatever room you wanted. And then like you could just directly program stuff. And it was interesting because when you would actually play MUD games in, say, the early 2000s or something, a decent fraction of the people, or like a much higher fraction of the people than you would think, than you would meet in your daily life, were blind, because that was like the game was all textual. And so it was one of those things where, you're not really going to appreciate World of Warcraft or something, but you could go on a MUD or something and then it just describes everything in the room and all that kind of stuff. So it was really interesting to see when like a decent fraction of the users are, just interacting with computers in a completely different way. You see some interesting stuff. If I think about this too much, I'm going to stop being the daytime guy and I'm going to just take up a second career as the accessibility guy.
Yeah, for sure. Well, it is super interesting. I hadn't really put that together, but of course, because it's pure text, you can have a screen reader. And like once you have the screen reader, it's pretty much on par with everyone else's experience. That's super cool. A cool bit of nostalgia there. So you got into this Moo. Somehow that led you into programming. Yeah,
so it was a programmable Moo. So that was like you could do object-oriented programming. So I was just doing little Moo scripting stuff. And then later I took up TickleTK. I had this job that I had these very long shifts and nothing to do. It was just kind of sitting around doing nothing, and I could play on the computer. So I bought a laptop and just programmed a Notepad clone. Then I went off to grad school, did a lot of MATLAB and some C programming. And then at some point, I was on some forum somewhere trying to make a point about something, and I made a chart in MATLAB and I posted it. And MATLAB has like terrible anti-aliasing, or at least it did at the time. And someone was like, oh, what is this alias nonsense? Like you should use matplotlib instead. So, and my friend had told me, the same one who had the Moo, he had told me about this programming language called Python that was like interesting and, like natural language text or something.
Fewer curly braces.
Yeah. So I just was like, all right, I'll give it a try. And then I really, really liked matplotlib. I rewrote my whole thesis, or I guess I just wrote my whole thesis, made all my charts in matplotlib. And then when I went and graduated and got a job, there was this one day when all the MATLAB licenses were taken on you had a certain number of site licenses. And if you ran multiple processes, it would take up 2 licenses. And I just couldn't do any work that day. So I was like, how about this? I'll just rewrite all of our MATLAB scripts in Python. And so then at work, I got to use Python. And then, I started doing open source, and I don't think I've used MATLAB since I left that job.
Isn't it interesting how these draconian licensing systems, like these license servers and other super intense things that are like just there to punish you, even if you follow the rules? It's like in their world, the worst possible scenario is that in some edge case, some user gets to run 11 copies instead of 10 when they only paid for 10. Whereas, they've lost all the goodwill and they've actually pushed you to just, we're just going to go do something that doesn't work like this at all. Those are really interesting situations.
That's one of the reasons I really like open culture is it just cuts down on friction so much. Like there are just so many times when it's like, oh, if I get this image from Unsplash instead of iStockPhoto or whatever, it's just, I don't have to think about it. I can use it however. And that's why I tend to create a lot of open artifacts. My blog is all CC0. I'm just really trying to cut down on the friction of letting people use my work. Well, I understand, like, my business model for myself is to sell my labor day to day to big companies. I understand how it would, if you are a company, you may want to sell software. I also totally love that I have to rent, so many things via cloud services. And I think part of that is because it's so easy to get around licensing restrictions. So I don't know, I'm of two minds, but I think wherever I can, just cutting down friction by using free and open source licenses is just makes everyone happy.
Yeah. Yeah. Well, I mean, look, there could always be some sort of grace slack area, right? Like, okay, you have 10 licenses, but we're not going to cut it off until you have 15 processes run. There's just like, when it's such a hard and fast rule, I don't know, it just cuts me the wrong way. All right, so you talked about some of the stuff that you've done at work. Gave me the sense that you're kind of just doing some consulting and helping out various companies on various projects. But what do you do day to day?
Oh, sorry. Yeah, no, I don't do consulting. I work for Google, so I'm less of a philanderer and more of a serial monogamist. So
gotcha.
Yeah. I worked for Bloomberg for about 4 years, and now I work for Google, and our team is called CorpEng Machine Learning. So CorpEng is our internal infrastructure team that handles things like facilities and like tickets. Like if you open tickets with people, like HR, things like that, those are all within CorpEng, and we build machine learning models for other people in CorpEng to provide them insights or to make their job easier, that kind of thing.
So this is like the Google scale of automate the boring stuff to help you do your work a little better.
Yeah, definitely. So, my day-to-day work is playing around in Jupyter Notebook. Well, okay, everything in Google is like its own proprietary thing, or even like when it's not proprietary, it's still its own thing. So like we usually use collabs. Unfortunately, I like to rag on people being like having their own proprietary versions of stuff, but like every time I try and do that with Google, like they have like stupidly good reasons. It just makes it so much less fun to make fun of our proprietary technologies when it's like, oh, well, they do have native integration with like Google Docs and Google Drive. So yeah, I guess it does make sense to use it.
Yeah, sure. I mean, there a lot is in the tech space and the developer space. Certainly the not built here, so we got to build our own sort of obsession where people could take that too far and it's just a drag. Like we don't need to build our own like booking system. We can just get a calendar system somewhere else and things like that. But when it's large enough scale and it has like built-in advantages, sure, it makes sense.
Yeah, I mean, I just wish that my colleagues were less competent because then I could make fun of them. But now I just have to respect them. What kind of a work environment is that?
Pretty good one. This portion of Talk Python to Me is brought to you by Brilliant.org. Brilliant has digestible courses in topics from the basics of scientific thinking all the way up to high-end science like quantum computing. And while quantum computing may sound complicated, Brilliant makes complex learning uncomplicated and fun. It's super easy to get started, and they've got so many science and math courses to choose from. I recently used Brilliant to get into rocket science for an upcoming episode, and it was a blast. The interactive courses are presented in a clean and accessible way, and you could go from knowing nothing about a topic to having a deep understanding. Put your spare time to good use and hugely improve your critical thinking skills. Go to talkpython.fm/brilliant and sign up for free. The first 200 people that use that link get 20% off the premium subscription. That's talkpython.fm/brilliant, or just click the link in the show notes. All right, let's talk about time. Every programming language has to deal with dates and times, and they all have their own way of doing it. And I would say Python's is pretty solid, right? It's got a pretty good system there. So there's a couple of interesting things, I guess, about time. One is it only goes back so far in computer time, right? If you're talking in ticks or things like that. So I don't know. What do you think about the datetime story in Python? Now that you're down in it.
I'm actually a big fan. I may not have a great breadth of experience outside of Python, but I think, the more I've learned about Python datetime, the more I understand the choices that were made. Like one of the biggest issues with datetimes is that you'll often see people like, oh, I can't believe datetimes are so terrible in Python because of XYZ. Like, why isn't every datetime UTC by default? Like, why is it some other naive thing, or like, why do I have to attach a different time zone to this or that? And the issue is that there are multiple camps of people who have equally strong, it should just be this way opinions, but in opposite directions. So most of the people think UTC is the natural thing to do, but I think those same people may not realize that when you're working with dates in the future, or you're working with civil times in general, UTC is actually a very bad choice, because generally speaking, UTC is good for, so I say UTC is good, and UTC is actually like the best that we have. I don't love that UTC has leap seconds in it, because it takes some nice monotonic constant that you can use as a reference, and turns it into this weird thing with its own edge cases where sometimes there are 60 and sometimes there are 61 seconds in a minute. Very annoying.
Really? I had no idea.
Yeah.
Every fourth minute has an extra second or something.
It can happen as many as 2 times per year. And sometimes I think they'll either skip the 59th second or they'll add 1 second. I think it's only ever that they've added 1 second. It's for the purposes of leap seconds. Leap seconds are, I think, useful for some things like astronavigation or something, but they're incredibly important for astronomers. I have no idea why they're built into the foundations of civil time. A regular human does not need to know to the second when the sun is going to be overhead in Greenwich.
Right. Maybe it makes more sense to have like an astro time that takes those like peculiarities into account, right?
Astronomy has its own whole big long set of ways of doing timekeeping. Like they have sidereal times and solar time, and I think they usually use the Julian calendar going backwards. I don't really understand exactly why they do all that stuff, but if you really want to dig into like weird timekeeping practices, astronomers are astronomers and weirdly astrologers. Like something you may not know is that a decent amount of the like historical corrections, and actually I think the original basis of a lot of the data in the time zone database that everyone uses came from astrologers who were like deeply concerned with exactly what second you were born at. So like if you birth certificate says like 3:15 and 14 seconds in Yugoslavia in 1981, they have to dig up the old Soviet era Yugoslavian timekeeping records to find out what that meant in UTC time, so that they could find out whether Jupiter was in the house of Aquarius or some crazy thing like that.
That is crazy. I had no idea.
If you don't cut me off on these things, I will just go on as many tangents like a weird fractal.
Right, tell me how they're still involved, and then I want to dig into something else.
Well, it's still important for them. So you'll still see corrections where they're very concerned with like times before 1970, because the record keeping is a little shoddier. And so the time zone database, basically they say anything after 1970, we try and keep it as accurate as possible. Before, it's best effort. So you'll still see people making sure they're like, oh, well, exactly how did the clocks move on the ground at this time? It's like the people who are on the time zone mailing list are basically a bunch of Unix people, the historians who are digging through, looking at historical stuff, and astrologers who are just weirdly concerned with exactly the minute you were born.
How interesting. I had no idea. All right. So what I want to dig into is this idea of naive time versus aware times.
Sure.
You can do interesting math, like you can subtract 2 date times, but I don't think you can subtract like a naive time from an aware time and stuff like that. Like you can't combine these things, can you? I don't remember. I feel like I've seen an error from that before.
That is true. So it's changed a little bit between Python 2 and Python 3, but not to the point where arithmetic is allowed between them. So in Python 2, there was this idea that a naive time was essentially just a representation of a time as it would show up on a calendar. So it's divorced from any notion of real time. It's an abstract, perfect datetime that just is the proleptic Gregorian calendar. And an aware time represents a specific timestamp. So you can take something that's in UTC and you can turn it into local time in New York or in Shanghai or anything like that. You can get durations between things. So that was the distinction. And, the idea was that it's kind of like a naive datetime was a datetime without a unit, and aware datetime is putting units on it. So the number 5 is just a number. 5 feet is equivalent to 1.25 meters or something like that, right?
Yeah.
It's 1.6 or something. In Python 3, it changed a little bit for reasons that are complicated and like probably not worth getting into. It's very complicated to create a time zone, like a TZ info that represents local time and maintains all the semantics that you would hope if during an entire process where the local time might change over the course of the process. And so one of the things that happened in Python 3 is that now, instead of naive times being unitless, they just represent local time. So they still act mostly the same way, but if you do something like you call .timestamp on them, they will give you, they'll convert it to UTC and give you the number of seconds since 1970, January 1st in UTC. You can also do like as time zone, and you can just directly, you can pass that a time zone, it'll convert, it'll assume that the datetime represents local time and then convert it into the time zone you care about. So at this point, local times are, or naive times represent local time, which is why UTC now and UTC from timestamp are not functions you should use these days.
Okay.
Because they basically, they generate a naive timestamp without attaching a UTC offset, or like without attaching the UTC object to it, but they do it as if that represents UTC. So if you do UTC now and then .timestamp, it'll give you a timestamp representing a different time than now.
Like I'm in -8, so it would subtract 8 hours from it or something like that, or add 8 hours rather. It'll plus or minus 8 hours, but it'll change it in some direction that's not just leave it alone. It was UTC now, so it is that time, right?
Yeah, exactly.
Okay, interesting. Yeah, I always feel like daytime seems so straightforward until you get into here, and then it's just like fraught with edge cases. You're like, wait a minute, what? I didn't know I couldn't use UTC now. Why is it still there, right? Without at least a warning.
It's even worse than you might think too, because the semantics of like subtraction are made even more complicated. And like the people who designed this library, like they weren't just like idiots. They actually were like really thinking things through. And so most of the time you won't even notice this kind of thing. But when you learn about it, it's a bit like makes your head explode. So there's subtraction works differently when you do it between the same time zone and a different time zone. So if you have two dates and they're both in New York time, right? America/New York. What it'll do is it'll subtract them just based on the calendar. It won't give you the total amount of time elapsed between those. Even if if it's like the day before daylight saving time transition and the day after, 23 hours have elapsed between 1 o'clock and 1 o'clock the following day. It'll give you 24 hours between those two if they're both in New York.
Okay.
Because that's how it works in the other direction. If you add 24 hours to something, it'll just shift over the calendar by 1 day. And I think the idea was that they wanted it to be the way it works in the other direction is you add 1 day and then it'll create something that's 1 calendar day in the future, and then it'll attach the same time zone object to the new datetime. So if you then subtract it back, you'll still get 1 day. The problem is that you can't just sort of shift around on the calendar when you're trying to do operations between two datetimes, like one in Chicago and one in New York. And the most reasonable thing to do is to just get the total amount of elapsed time. You just convert them both to UTC and say how much time has passed.
Right.
The thing is that the way they decide between interzone and different zone, like same zone and different zone, is whether the objects are the exact same object. So if you construct a new time zone object, if your time zone provider allows you to create a new time zone object representing the exact same zone, it won't check if they're equal. It'll just check if they're the same object. This is not really a problem with PyTZ because PyTZ doesn't use normal datetime mechanisms, and basically literally everything you do will generate a new time zone object. So everything is an interzone comparison.
Yeah.
And with Datetime and with the new zone info module, I've implemented a cache. So basically all of these zones are singletons anyway. So nowadays it's basically like if you use the same INA key, you'll get same zone semantics. And otherwise you'll get different zone semantics. It's more complicated than you would think. And it's really just all down to these overloaded concepts that are just everywhere in datetimes. Like the idea of adding a duration is horribly ambiguous, right? If you consider adding a month, right? What does that mean? Does that mean 30 days? Does it mean 31? Does it mean give me the same day, the next month. What if it's January 31st? Do you go to the end of February? Do you go to the beginning of March? So for 2 days, if you add 1 month, does it all go to the same day? Like, do you just do 1 month mod, however many days the difference is? Like, there's so many different options. You kind of have to pick one, but it's very frequently the case that different users will have different, very strong expectations that it will do one thing or the other. And for something so low level, like the datetime module, which is, essentially something like a standard, right? It's trying to be basically a data type, an interchange type. You just have to make choices that are hopefully going to be useful for the greatest number of people.
Yeah, well, it makes a lot of sense, but man, there are more and more edge cases. The more we talk, I'm like, yeah, that's tricky. And you think about, so if I was in Indiana, for example, like certain places in the United States have different rules about following things like daylight savings, right? So Arizona, Indiana, a couple others, but I pick on Indiana because they've got a county by county system. So depending on which county you live in, like here, actually, let me just read this bit from Wikipedia just so people know what I'm talking about. It says, most portions of the state that were in the Eastern time zone do not observe DTS, daylight savings. However, Floyd, Clark, and Harrison counties, which are near Louisville, Kentucky, and Ohio, and Dearborn counties, which are near Cincinnati and Ohio, unofficially observe it because of their proximity to these cities, which do observe it. So if I have like 2 date times, one in that county or not in that county, right? It's in different time zones in different parts of the year based on like region. Like, what do you even do there?
Well, in the time zone database, the INA time zone database, it's also sometimes called the Olson database. What they have is that, it's one of the reasons why names like US/Eastern and US/Pacific are actually deprecated. The way those keys work is that they usually go with a region / the largest city in the region that has continuously used the same rules since 1970. So America/New York is the same one that you use in
like
New
Virginia
York,
or something.
as in Boston, or in Virginia, anything like that. If Massachusetts switches over to being part of Atlantic Standard Time, then there will be a new zone created called like America/Boston, and it'll cover Massachusetts going back all the way to 1970. In Indiana, they have their own like sub key. So they have like America/Indiana/Indianapolis, and then like 5 different states there. I think Mountain Time has a couple things like that as well. Like Denver and Phoenix are handled separately.
I see. So you have to be very precise about your time zone info passed over, but then it'll actually take care of that.
Yeah, it definitely handles that in terms of historical times. Like this gets to an issue that it's another one of these overloaded concepts, which is like when we talk about a date time, for some people, like if you're looking at server logs, people are like, why would you not just use UTC all the time? It's unambiguous.
Yeah.
But those people are not implementing, say, a scheduling service, right? Where, like you and I schedule to meet at a specific time to record this podcast.
Right.
If someone had changed daylight saving time, like if between the point where I scheduled it and today, the United States said, we're in so many crises right now that we're just going to like switch off daylight saving time. I don't know why politicians love messing with time at the last minute, but they absolutely do. If someone had done that, then we would still want to meet at 4:00 because relative to my work schedule and your work schedule and everyone's school schedules, that's still the right time for us to meet. But the mapping between 4:00 and UTC will have changed. So what that means is like, if we had recorded that as saying, okay, this is going to be, as a daytime guy, I should always be embarrassed by this, but I can never do any daylight saving time calculations in my head.
Hey, we have computers for this stuff. Come on.
Yeah. It's like 8:00 UTC is when this recording is going to happen. If all of a sudden the mapping between 4:00 and 8:00 changes, you and I will be very unhappy that they stored it in UTC and then converted it before showing it to people. So when you're dealing with, the distinction I usually make is timestamps versus civil times. So a civil time is like when you actually care what the clock on the wall says, then you should use a civil time, which is you store exactly what the clock on the wall says, and then the time zone you stored it in, America, New York, something like that.
Right.
This is to get back to this point about what you do, like how you store it. Right now, there's no way to solve exactly that problem, or there's not a great way to solve exactly that problem, because what you really care about is like a little hard to pin down because, I'm in New York, you're in Portland, right?
Yeah.
So, if one of us changes our time zone, if our relative time zones change, New York changes its time zone offset, but Portland doesn't. Which, the meeting is with two people. Which one controls? Which one matters? Or like,
right.
I said it's America,
Do you
New York,
reorient it based on like the current understanding of time in New York and then break Portland, or do you stick with Portland and now you're out of sync?
I think the best you can do is you pick an INA zone and you just store it that way. Usually that won't be a major problem. If you're like super belt and suspenders, like storing a user's location, you say like, where is this meeting, or like, where's the rules that you care about? And then you'd have to find a library that maps locations to time zones as a function of time, and then just make sure that that library is kept up to date. That should sort of sort you out. But I think the best you can do is to monitor the time zone mailing list and, just be aware if you see anything that's going to affect you.
Yeah. Well, there's definitely a lot of little edge cases, and that's pretty interesting. So another thing that's interesting in the whole time space of Python, and I think is done pretty well, is time deltas, right? And the fact that I can have 2 date times and I just subtract them, and that gives me a time delta object, or I can have a date time and then add or subtract the time delta and that generate a new date time that's offset by that. What's weird about time deltas that I should be learning about? Because they seem pretty straightforward. I would like to see them do a little bit more help for people, but this is already pretty good.
The biggest thing semantically is an issue that I already alluded to, which is that they're a little overloaded in that sometimes they represent an elapsed amount of time, and most of the time, and usually they're interpreted, when you like apply them to something, they're usually interpreted as a calendrical delta. So it's like, it'll give you, if you add 1 hour to something, if you add 1 hour to like 1:30 right before a standard time to daylight saving time transition, what you'll get is some non-existent time that is right in the middle. Like, it's like a 2:30 that never happened. Or you add 1 hour, like 1 minute to right before that, you'll get, or you add 1 hour and 1 minute in such a way that it spans that, you'll get something that is nominally 1 hour and 1 minute away, but in fact, 2 minutes have elapsed, something like that.
Right. Okay.
So that surprises people. I think it tends to surprise people more on certain scales, like for very short time scales, 1 minute, 2 minutes, something like that. You're like, why isn't this working exactly as I expect? When it's like 1 day, you're usually trying to just get the same time the next day, something like that. I don't know that there's a great solution to that. One thing that I would kind of like to do, and I don't know that there's any way to do it without breaking backwards compatibility, is to separate out the concept of a calendrical delta and an absolute delta, which is like, give me this elapsed period of time. You can certainly add a type that represents elapsed times, and then when you add it to a date time, it converts the date time to UTC, does the addition, and then converts back. But the issue there is that what you'd really want is the results of those interzone subtractions to return those elapsed time time deltas, because that's actually what's happening. You're actually getting an elapsed time delta. So if you take something that's like something in America, Chicago, minus something in America, New York, you'll get the absolute exact time. And then if you add that to America, New York, and then convert the result back to America, Chicago, you might get a different value than the value that you started with. So like that property is something that you would expect to be true.
Right. That idempotency of like, if I change it this way and then I change it back, or that sort of additive identity or whatever you call it there, that like I make this change and I undo that change. It would be weird if it's like not back to where it started and stuff, right?
Yeah. So, I mean, in that very particular edge case, it is a little bit lossy, and I would really like it if there were a bit that I could add. And maybe you could, like, maybe everyone who is seeing this behavior is expecting that like reversible transformation, and basically we would just be fixing a bug for every single person. But there may be people, like, you always hate to punish people who figured out the right thing to do and then did it, and then you just like changed what the right thing to do is out from under them.
Yeah. Once you've kind of put it in place, then it's really hard to change it, right? I mean, you're kind of stuck.
Yeah. I mean, that's the story of my life, but you make slow and steady changes, and you break things only when you absolutely have to. And hopefully you get a reputation for not breaking things just willy-nilly, and people take you seriously when you say, hey, we really want to break all your stuff today.
Yeah. Well, I think that's actually one of the reasons that Python is going so strong, right? JavaScript is going strong as well. But the challenge with JavaScript is like, I spent all the time learning Angular, and then they threw away Angular 1 and they rewrote the API and they switched it to TypeScript. So I got to start over. Or, like pick your framework du jour. Like the stability of those things or the life cycle of those things is so short. And, the fact that you don't have to keep changing because your dependencies or whatever changed, that's like dependency being Python potentially. That's a really good feature, I think.
Yeah. Well, I think sometimes also things have tend to have a short shelf life in some situations because people want to break a whole bunch of stuff. And I guess I'm just glad that we have maintainers around who are willing to kind of put in the work for the long haul to make it so that, hey, this thing is still supported and you don't have to migrate to a new framework every 30 minutes.
Yeah. So one thing about timetimes that I want to ask, time deltas that I want to ask you about, because it drives me crazy, is I find myself doing math way more than I think I should with time deltas. For example, if I have a time delta and I want to know how many days that time delta represents, that's a math problem for me, right? It has a days operation, a days property or field, but it gives me unusual answers in some sense and not a fraction of days, right? So if I have something that's 30 seconds, I would like it to be, I don't know, whatever that is, like 1/100th of a day. Or I would like to be able to ask, how many hours are there? How many weeks? Months and stuff starts to get hard. Okay, how do I do it? Because all I know about is total seconds, for example. And then there's seconds, and then there's microseconds, and there's days.
Those accessors, like the days, seconds, microseconds thing, those are actually... Time delta is essentially supposed to be like a struct type object that just like holds a time delta, and it has three canonical components, which is days, microsecond, or days, seconds, and microseconds. I understand that it's confusing that those accessors are like not the total number of days. The way you're actually supposed to, this was added in Python 3, the way you're supposed to get this information is time deltas can just be divided by other time deltas. So if you just have like a time delta and you want to know how many days there are, you just divide it by time delta days equals 1.
Oh, interesting. So instead of going total seconds divided by 60 divided by 60 divided by 24, I would say DT divided by time delta days equals 1.
Yeah. And you can just have any arbitrary value as the denominator there. So it's actually, this is one of those situations where it's like not super discoverable, but it's incredibly elegant.
Yeah.
And like the fact that total seconds even exists is a problem. Well, it's not a problem, but it highlights this fact that it's not super discoverable because when they added total seconds, they had already added the ability to divide by, they had already solved this problem by defining dunder div.
Yeah.
And one core developer didn't know about that and added total seconds. And then the guy who was, maintaining Datetime showed up after it was all merged and stuff and was like, oh, I wish I had seen this before. I would have said, please don't add this.
Yeah.
So, every once in a while we get people who show up and they're like, can we get total microseconds and total whatever? And it's like, we don't want to make 40 different, things that say quarters and months and years and things like that. Like you just have to divide it by a time delta. And it works super well, especially now that increasingly people are working in Python 3 only code bases. If you have a 2.3 compatible code base, you generally do have to do total seconds and then divide that by total seconds of whatever your time delta is.
Gotcha. Okay. Interesting. Yeah, because I was hoping there would be a total minutes, total hours, total days. And it could just do that math that I talked about just inline, right? And just so I could be more expressive and not do a long series of divisions.
You certainly can do that. I can understand why you would want that, I suppose. But then, you only have the enumerated units that are in there. And it also sort of hides the fact that you can just do regular division. I mean, you don't have a dozens method on integers to find out how many times 12 evenly divides in it. It's a fair point.
I think that's the discoverability that is the challenge, right? To know that you can actually do the division and because now you say it, sure, it makes total sense to say, I want to know how many whole weeks are in there. So I would say time delta days equals 7 and then divide it. And that would give me a great answer, right? And I can pick my units to be whatever.
Yeah, you can also do weeks equals 1.
Yeah. Yeah. Weeks equals 1. Sure. So there's a lot of flexibility there. But yeah, it's just, I don't see a lot of examples using that, when you look around at code and stuff.
That's partly because people don't see it and partly because anything that, a lot of the code that we look at now, especially open source code, has been 2.3 compatible for like the past 5 or 10 years or something. And that idiom is not available in Python 2. So Python 3, when you're Python 3 only, it's kind of like you're starting to see F strings everywhere. Hopefully all the cool kids now are just dividing their time deltas.
Well, they will be now that they hear about it on the podcast.
So yeah, I thought you were going to say the thing about how the repr and the stir, like the string cast of time deltas, is just absolute trash. Like, I really wish I could fix that. I think it's going to be difficult to do so, but it's like, if you print a time delta that is -1 hour, it tells you 1 day minus 23 hours, or it tells it to you in seconds.
Yeah, the internal representation is weird. Like, so if I do that for one that is 1 second long, it's -1 day, 23 hours, 59 minutes, and 59 seconds. If it has like a -1 second or something in it. Yeah, it's, it computes to the same, but it's not very human.
Yeah, I would probably do it a different way. I would probably do it as like negative and then abs, like, and the absolute value. I think they're worried about some ambiguity there, but I don't think anyone ever wants what we got. So
yeah, you've given like 99.99% of people something they don't want to avoid a tiny bit of possible ambiguity. That's right.
Yeah. But what are you going to do?
Well, so let's talk a little bit about some of the PEPs here. So you've got PEP 495, and is that one already done? That one's already done and dusted?
Yeah. So PEP 495 was implemented for Python 3.6, and that adds the fold attribute. The background of this is that prior to Python 3.6, time zone support was not super great. Basically, whenever you have an offset change where the offset decreases, that means that you are jumping back by an hour or by any amount, and that creates an ambiguity, right? So it's 2 o'clock, and then you jump back 1 hour. Hopefully it's 2 o'clock. I actually found one place in Argentina in 1992, their daylight saving time transition happened at midnight on February 29th, because it wasn't bad enough to do it at midnight with that ambiguity. They also had to do it during leap day.
Oh my goodness.
Yeah. So it's like, anyway, so you do something like that, right? And so instead of it being February 29th or March 1st, it's now February 29th and at 11 p.m. a second time. So the way time zone handling works in Datetime is actually quite elegant. The idea is that you attach, because a time zone represents a set of rules for like taking for mapping between absolute times, like time in UTC, and local time, like what time does it say on the clock. So I think the original design intent was that you would have a tzinfo, and the tzinfo has these functions that you can call that give you information about the time zone as a function of the date time. So it's super great. You just write this function that maps your date time to UTC and you're done. Except that the date time portion is sometimes ambiguous, right? So if it's 1992 and it's 11:30 in Argentina on February 29th, there are 2 different offsets. There's 2 different sets of information that you could apply there. And there's no function that you can write that just takes the naive portion of that date time and gives you the correct offset because it's ambiguous. So the way PyTZ solved this problem was that they added this localized concept where what they do is you create a time zone, and then instead of just like attaching it directly, you have to call localize on it. And what PyTZ will do is it'll just attach a dedicated fixed time zone offset. So it has a little switch in there where you can say, do I want to be on the daylight saving time side or the other side? This is a major source of bugs because people will just do what the docs say and attach PyTZ time zones directly to the tzinfo instead of letting PyTZ do it itself. And also it kind of circumvents a lot of the other logic in there about a lot of assumptions about like you're just supposed to have this one set of rules, not a fixed set of offsets. And then it's also a bit of a problem because they specifically use DST, but there are situations where you have transitions that are not due to daylight saving time, like someone just switches their base offset or something. So that's where PEP 495 came in. What they did was they said, we're just going to take the naive portion of the date time and we're going to add an additional component to it called fold. And that can take 2 values, 0 or 1. The 0 represents the offset that happened before the transition. And then after the transition, you put fold equals 1. It's very elegant. It allows you to write time zones that just take the naive portion of the date time and then just flip a switch if it's ambiguous based on the fold.
Okay. Yeah, that's cool. Yeah, just catching these little edge cases. And then PEP 615 you're working on as well. And this one's in 3.9. So I guess in a sense it's accepted because 3.9's in its beta world.
Yeah, it was accepted and we merged it. So it's going to be, you can get it in the betas now. You can actually get it. I have a backport of it implemented back all the way to Python 3.6. It works in PyPy. I've tried to make it, my goal here is basically that I would really, really like it if people could stop using PyTZ. I think the maintainer of PyTZ would also agree with me on that. Mm-hmm. It's basically, PyTZ was sort of a hack around this issue. They did a really great job on it. Like, I don't know that there's a better way to have done that. But, well, other than just coming up with this fold idea yourself, and that has its own problems. In Datetime, I also have a backport of PEP 495 that works in 2.7. So even if you have a Python 2.7 implementation with some combination of the zone info module, which was added in PEP 615, and Datetime, you can actually get proper PEP 495 support all the way back to Python 2.7. And yeah, there's a bunch of reasons why you should use zone info. One is obviously I think it's enough of a selling point to just say you don't have to do this localized, normalized stuff. Like you can just use time zones like they were meant to use and it'll just work. But there's also the fact that PyTZ doesn't have any support for the version 2 TZIF files. So the compiled versions of the INA time zone, they're all version 2 or 3 now, like since 2005. And version 2 and 3 is when they switched from using 4-byte integers to 8-byte. So each time zone now starts with version 1 file, like the entire version 1 file. And then after that, they have the version 2 file. So all the stuff that supports version 1 files only still works with your version 2 and 3 files, but version 2 and 3 files will go past 2038. And they, instead of just like stopping at some point, they also have like a general rule. So they'll say like, here's the rule for transitions after 2038.
Right. We don't have data for this, but here's how it has been. So just keep computing it like this.
Yeah. I mean, the further into the future, and actually the further into the past, like the distant past, like just like what was the time is significantly less meaningful question to ask. So right now, what time zone, like what is the UTC for New York in 2040 is not a terribly like gazing into a crystal ball, right? It's
right.
You can have a guess. It's probably a better guess than randomly choosing, but it's not going to be accurate. Like it might be a bit of an XY problem if you're asking that question, but it's still like, at least it'll do what you expect. But as time goes on in the next 10 years, in the next 15 years, we're getting a lot closer to 2038. You're going to need that kind of support.
Right.
So yeah, PyTZ doesn't have support for that. It doesn't have support for sub-minute offsets. Another thing that zone info does and Util does, but PyTZ does not do, is that they will hit your system time zone information first. So there's a way to configure it. They have their own access to time zone. They have their own time zone data in a sense that you can get if your system time zone data, if your system doesn't provide time zones. And there are mechanisms for specifying where you want to get the time zone data from. But with PyTZ, it ships the time zone data with it. So you have to keep your PyTZ up to date just to get the data updates. There's a way to change that where I think you like set an environment variable and tell it where your system time zones are, and it'll use that instead of its own thing, but you have to know where your stuff is. Whereas with zone info, it's built in, so it'll find it in the most common places, and then there's a mechanism for the person who distributes Python to you to tell the compiler where it's going to be. So if you use some system Python, it'll always hit your system time zone, which is very helpful. So, there's all those reasons to not use PyTZ.
Yeah.
There's still reasons why you might be worried about switching over. Like, for example, since PyTZ has its own weird interface, there's going to be a lot of your users possibly who've taken your TZ info and they've called localize or normalize on some date time. And if you change over from PyTZ, it's going to break all of them. But I am aware of this kind of thing. So I've also created a library called PyTZ deprecation shim, which is just a thin wrapper around zone info, except that it supports the PyTZ interface as close to the semantics that PyTZ has as possible, and then it just raises a warning if anyone's doing anything PyTZ specific. So it just works like a regular 495 thing. It works in 2.7 and 3.6 onwards. And if anyone's like using localize or normalize or whatever, it'll raise a warning. So you can basically say, for the next 2 years, I'm going to depend on PyTZ deprecation shim, and then I'm going to drop it in favor of zone info. So, and hopefully everyone has not been ignoring all my warnings.
Yeah, that's good. It's really nice to have that warning there. So it gives you some time to deal with it. All right, Paul, we talked about a lot of different things, a lot of interesting edge cases and scenarios. Maybe give us the main takeaways. Like if you could give people listening some advice on the please do and please don't with time in Python, what would you say?
Yeah, so for don'ts, I actually have a couple of blog articles about this. Like one of the things I see the most often is people using UTC now, thinking like, I want something in UTC, but UTC now and UTC from timestamp are not something you should be using in modern Python. I would like to remove them, but there are like occasionally these situations where they're useful. Like if you're immediately if you're just using UTC now and then dumping it right into ISO format, and you don't want the UTC offset in there.
Right.
It's not a super great way to do that. I might just bite the bullet and deprecate those, and then maybe, have a wrapper function for it in Datetime. But for the most part, you don't want to use UTC now. You should use just datetime.now and then pass it the datetime.timezone.utc object, which is just a UTC singleton that's in a standard library. Also, I don't think you should use PyTZ. I think you should take all your PyTZ code and migrate it over to zone info or Datetime and start getting on the PEP 495 bandwagon. And
cool.
I've got a little migration guide for that.
Nice. We can put the links to those in the show notes. Now, I just want to maybe acknowledge a couple of libraries that are on the outside of CPython, but still pretty helpful. And the first one actually is Python-Dateutil. That one's yours, right?
Yeah, so I didn't write that, but I've been maintaining it for about 6 years. That's got some interesting stuff. Even after PEP 6.15, the time zone module does still have some useful time zones in it. Like it has, I say useful. What I mean is like available time, like different types of time zones that are not in the standard library. So like there's this TZ iCal. If you have time zones in this iCalendar RFC format, Datetime will handle that. And you can also use these POSIX strings. Like if you ever see like EST5 EDT, and then there's a POSIX standard for expressing recurring DST transitions. So it has that and some Windows specific stuff as well.
You know what I use it for that I really like is its parse. Its parsing is really good because it seems like it generally just handles time strings, which is great.
Yeah. The parser is the part that I like the least, but that's mainly, because I have to maintain it, and it's got so many rules that it's super easy to break. So anytime someone shows me something where it's broken, it's like, I'm really afraid to change anything, because if I do, it'll break someone else's use case that they've been using it for like 10 years. It's also like pretty slow. So it's super useful if you have something that you know is a datetime and it's in a pretty standard format, and you just want it to chew at it until it finds something that looks like a datetime. But it could be chewing for 200 microseconds. If you have something that's in ISO 8601 format, Datetime also has ISO parse, which will handle anything that's in a valid ISO 8601 format. And then datetime, I think the first thing I added to CPython was from ISO format, which is the inverse of ISO format. So
that's cool. That's on Datetime.
It's got R rule. Datetime also has R rule for recurrence rules, which are very useful. It has relative delta if you want to do time deltas, but include years and months and things like that. And the best one I saved for last is Easter. It just tells you when Easter is. You give it a year, and it's like, this is when Easter is.
Oh, that's cool. Yeah, there's a couple of different holidays and stuff that are all over the place that that are tricky, like Hanukkah and stuff. So the two others that come to mind, and I'm sure there's 10 additional libraries that people are out there listening, but this one, I just don't have them off the top of my head. One is called Arrow. Are you familiar at all with Arrow?
Yeah. I've contributed to Arrow a couple times.
Yeah, it's pretty cool. It's some of the things, I guess, that stand out to me, that caught my attention the most, is that it has humanize. So you can have a time and you say .humanize, it'll say an hour ago. Then you say humanize an hour, the locale is Korean or something, and then you get the Korean statement of an hour ago and so on. And that's pretty easy. Pretty nice.
Yeah. I mean, so for stuff like Arrow and Pendulum and Maya and DeLorean and all these things, I've never found a huge amount of use for them, but I'm not like a huge, like, I don't know that I have the exact use cases. I tend to write libraries, and taking on big dependencies is not the easiest thing for me. But I do know that people kind of swear by these libraries. They really like them. So I think that there's certainly something to them. The biggest problem I have with them is that they tend to try and advertise themselves as like drop-in replacements for datetime. And so they then subclass datetime and time delta. Stuff like Pendulum advertises itself as a drop-in replacement, but then it breaks all the stuff that I want to break, so it's not actually a drop-in replacement. You can't even construct it the same way. And they tend to be slow as well. I mean, this is partially because they're not written in C, or not mostly written in C, but, to do simple time delta arithmetic in Pendulum is like 10 times slower than doing the same thing in C. But, if you're not handling a huge number of daytimes, it's probably fine. Yeah. But of course, we don't have human eyes and things like that in the core. I think that those are very useful things. I would love to see a library that is kind of like Pendulum or Arrow, but instead of it being methods on a datetime subclass, it's like just free functions, utility functions.
Right. You could pass it built-in items. Yeah. Yeah.
I mean, I think that would be faster in a lot of ways. Sometimes people don't care about fast.
Yeah. Yeah. Well, if you're building a library, especially if you're building CPython itself, it's a different level of concern. Yeah. If I'm rendering a web page and I've got 10 items and I want like the human expression of how long ago they were, I probably don't care.
Plus, you can benchmark. I can you can benchmark and see where the bottlenecks are. I can't benchmark everything on PyPI and in everyone's proprietary code bases and find out do some sort of optimization and find that this is not the bottleneck anywhere that this code is being used. So
right, exactly.
It's a different scenario. And yeah, I do find that just using bare datetimes is useful for interop, but if you're mostly working in your own stuff, like you're just passing it around, doing stuff with it, they do have some people do like it. They really do like the interfaces. They like that the time delta things that they give you have total minutes and that they have human errors.
Right. Yeah, they got like weeks and hours and stuff. The thing that stands out as most unique about Pendulum is they have a duration period thing that is aware. So I could have a datetime span, the subtraction between two datetimes, their equivalent of a time delta. And then you can say in weekdays and then for each thing in the period, and it'll give you day 1, day 2, skip the weekend, day 3. So, Thursday, Friday, Monday, Tuesday as a thing you can go. So if you're like, well, it's this long, I need to know how many weekdays there are or how many weeks or something in this span. That's an interesting concept.
Like in Util, we have this R rule, which is based on a data type described in RFC 5545 called the recurrence rule. And it is super, it's a little more complicated than that. Again, this is why I think these sorts of things could be done as free functions. It's very interesting. And it's a little too complicated for the average person to just sort of jump right into it. But you can express all kinds of stuff like that and say how many Tuesdays are there? One of the talks I give on Datetime, I think I say how many times did the guy who played Mr. Miyagi, Pat Morita, how many times did his birthday fall on a Tuesday during the Vietnam War? And I have a simple R rule that is standardized. You can cast it to a string and pop it into Google Calendar. And I can just easily do that with an R rule. I say easily, but that's after maintaining an R rule library for years, right? You're a random person.
But it does it.
I don't know.
Yeah, it's like saying you can find that with a regular expression.
Yeah. Right. Yeah.
You can just easily do that with the regular expression. You can easily do that with the regular expression. I will struggle with that regular expression, but it's fine. But it's powerful. It's cool. All right. Well, I think that's probably it for all the time we have. We've run out of time talking about time, but there's been a lot to talk about. It's very interesting. Thanks. So before you go, though, let me ask you the final 2 questions. If you're going to write some Python code, what editor do you use?
I usually just dictate that to my secretary, and no, just kidding. I usually use Vim. I don't feel strongly about it though. So if anyone wants to, don't try and convince me about it, but also don't see that as an attack on your Emacs using ways. I just picked one at random.
Sure. Sounds good. And then notable PyPI package?
There's one that's really fun, but please don't, if you install it, do it in a virtual environment or something. It's called Break My Python. you pip install it, and then it just makes it so that your Python is broken. Like you don't have to import it to have your Python be broken. You just do pip install break my Python, and if you type Python, it won't work anymore. It'll just break it.
That's break dash my dash Python. All right, so that's kind of an anti-recommendation. That's interesting. Very cool. Funny.
If you want a real recommendation of something that's like fun and useful to use, is I actually do like pipx.
Oh yeah, pipx is cool. I love pipx.
Yeah. At this point, my main Python installation stuff is like super layered with all kinds of indirection. So like everything is all PyEnv environments. So like I have 10 different Pythons installed, but even within those, I never pip install anything directly. It's either like I'm working in a virtual environment, or if it's tools like Tox or virtualenv or something like pep517. Well, actually, that one doesn't really work.
Like Glances or PTPython or any of those types of tools. PyTest.
Black, MyPy. Yep. PyLint. All that stuff. You just do pipx install whatever. You do it like you're going to pip install it, but what it does is it will install each one of these tools into their own virtual environments, and then just put on your path the entry points that they expose. So you do pipx install MyPy, and then if you open your Python and try and import some MyPy-like thing, it won't be there. But if you just type MyPy, it'll work as if by magic. And this avoids the whole situation of like different tools stepping on each other's dependencies or needing to update all that stuff. It's really great.
Yeah, I really like it. To me, it feels like homebrew for Python utilities and applications, right? Like on my Mac, I can brew install MongoDB, I can brew install ffmpeg, all these things that I might need, and they'll be installed separately and maintained, and when there's updates. Pipx is that for things that are tools based on Python that you would pip install them. It's really nice.
Yeah, I mean, except Brew also kind of maybe has that same problem, right? Where because it's like a system package manager. I mean, they handle it for you.
Yeah, it's a little more. Yeah, it's less isolated. Yeah, I agree.
Yeah. I mean, as long as you're not using your Brew Python, right? Like if you don't open up Python that you Brew installed.
Exactly. Cool. All right. Well, pipx is a fun recommendation, and break my Python is a good joke as well. All right. I'm looking forward to digging into that to see how it actually breaks your Python. All right. Well, thank you for being here. Final call to action. People want to get their time zones and time in order. I mean, obviously, the recommendations you had, the do's and don'ts, stand, and we'll put a link to those. Anything else you want to leave people with?
I think it's pretty good. Like, I think I'm very interested in getting people to migrate over to Zone Info. So, especially right now, when there's not a huge number of people knocking at my door to ask about that, but feel free to, open some issues on there, or send me an email, or at me on Twitter or something. And get out there and, maybe like tweet or Instagram or TikTok or whatever the kids do these days to all your friends about how great PEP 615 is. And hopefully we can get the word out that you don't have to use PyTZ anymore. Yeah, absolutely. Well, thanks for working on all this stuff and handling all these edge cases for people. That way we can mostly ignore them, except for when we can't. Yeah. Yeah, thanks. See you later. All right, bye. This has been another episode of Talk Python to Me. Our guest on this episode was Paul Ganssle, and it's been brought to you by Brilliant.org and us over at Talk Python Training. Brilliant.org encourages you to level up your analytical skills and knowledge. Visit talkpython.fm/brilliant and get Brilliant Premium to learn something new every day. Want to level up your Python? If you're just getting started, try my Python Jumpstart by Building 10 Apps course. Or if you're looking for something more advanced, check out our new async course that digs into all the different types of async programming you can do in Python. And of course, if you're interested in more than one of these, be sure to check out our Everything Bundle. It's like a subscription that never expires. Be sure to subscribe to the show. Open your favorite podcatcher and search for Python. We should be right at the top. You can also find the iTunes feed at /iTunes, the Google Play feed at /play, and the direct RSS feed at /RSS on talkpython.fm. This is your host, Michael Kennedy. Thanks so much for listening. I really appreciate it. Now get out there and write some Python code.